The spring sun rose sluggishly over the tarmac at the airfield just outside Tokyo on a clear morning in May 1944. On runway 11 at Tachikawa Airfield, the prototype of the new Japanese Army fighter, number 1446, sat nose down, its radial engine idling with a deep mechanical growl. Pilot First Lieutenant Hiroshi Sugimoto climbed into the cockpit of the Nakajima Ki 84, Hayate, the Frank, and settled behind its armored canopy. All around him were the technicians and engineers of the Nakajima Aircraft Company, younger faces drawn tight with hope and exhaustion. They believed this fighter would at last shatter the air superiority of the North American P-51 Mustang. Before we jump back in, tell us where you're tuning in from. And if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Sugimoto pressed his helmeted head against the reinforced headrest, the smell of oil, hot, metal and aviation fuel heavy in the cockpit. Slowly, the throttle lever rose. The Ha-45 Homar engine, rated at nearly 1,800 horsepower in its production form, roared to life. The wide-track landing gear lifted, the aircraft rolled, the chain link of control rods vibrating as the Hayate accelerated down the runway. Dust and gravel flicked aside. At 150 miles per hour, the wheels left the ground. Sugimoto felt the climb rate immediate, exceeding anything the earlier Japanese fighters had delivered. He leveled at 15,000 feet, checked the airspeed indicator. 387 miles per hour, then 395, then 400. The needle trembled. In that moment, as the morning haze of Tokyo suburbia fell away beneath him, the belief sharpened into conviction. Japan had built a fighter to beat the Mustang. Yet in the months ahead, that conviction would unravel not by enemy fire, but by failures of production, material, adaptation, and timing. The question posed by that day's flight would linger. What happens when engineering brilliance collides with industrial collapse? To understand the meaning of that moment, we must go back further to the founding belief that this fighter could reverse Japan's faltering war effort. By early 1943, the war in the Pacific had become a contest of machines as much as men. Allied bomber formations numbered in the thousands. The P-51 Mustang had entered service, offering long-range escort, speed, altitude, and firepower that challenged Japanese air defenses. Meanwhile, the Japanese home islands were increasingly vulnerable to B-29 raids, and the Imperial Japanese Army Air Service, JAF, sought a fighter that could intercept bombers at altitude, hold its own against the Mustang, and restore the legend of Japanese air superiority. The Nakajima Design Bureau, under chief designers such as Jiro Horikoshi, earlier of Zero fame, and engineers at Nakajima Aircraft Company, turned their attention to creating a high-performance fighter around the new Nakajima Ha-45 Homar engine. Their specification demanded speed, firepower, and pilot protection. Two 20mm wing cannons, two 12.7mm machine guns, armor-plated cockpit canopy glass, self-sealing fuel tanks, and a climb rate to intercept high-altitude bombers. The result was the Ki-84 Hayate indeed, produced in the thousands over 3,500 by war's end, and featured the combination of speed, armament, and maneuverability that threatened to outmatch many late-war Allied fighters. Japan's belief system around this fighter was embedded in its wartime propaganda and internal doctrine. After the early victories of the A6M0, which soared on the reputation of maneuverability and surprise, Japanese air doctrine struggled to adapt in the face of higher altitude and heavier Allied fighters. As historian Mark Carlson puts it, no matter how good a plane is, the outcome of any aerial engagement usually comes down to the skill of the pilot. Yet by 1943-44, the JAAF recognized that speed, protection, and firepower counted more than nimble turns alone. On factory floors at Nakajima's plants in Ota and Utsunomiya, the Hayate was given the nickname Gale, Hayate, a fighter meant to break the wind, break the bomber stream, and restore Japan's lost initiative. Its development timeline was compressed. First flight in April 1943, introduction in June 1944. The belief held that it could match, even exceed, the Mustang at critical altitudes and thereby shift the psychological balance of air power. This belief was not just technical, it was existential. Japanese pilots defending the home islands were told that this aircraft would give them the tool to defend the homeland, to exact payback for lost islands and broken naval carriers. The airfields around the Kanto Plain became production hubs, and the Hayate was featured in newsreels as the fighter of the homeland, carrying the weight of national hope even as raw materials and experienced pilots were in decline. Yet, beneath the polished show flights and optimism lay deeper problems. Japan's industrial base was being strained by Allied bombing, shipping blockade, raw material shortages, and the loss of skilled labor. At the same time, the design of the Hayate demanded precision tooling, high-grade alloys, and careful assembly luxuries Japan could no longer guarantee. The paradox was set: a plane capable of beating the Mustang under perfect conditions, deployed too late, built too thinly, in a war already turning against its makers. In the air that clear morning at Tachikawa, the prototype flight had shown that the belief was not entirely misplaced. The climb rate, the agility, the power of the engine, all combined to give the pilot a visceral sense of what might be possible. But in that sense of exhilaration was also a subtle warning. The landing gear collapsed once. The engine vibrated beyond standard tolerances for longer than expected. The structural radiators ran hotter than predicted. These datasheet anomalies, quietly recorded in the logbooks, would later become open failures when production aircraft faced combat conditions in the Philippines and over Kyushu. What followed was the collision between belief and reality, a story of ambition, material failure, psychological shift, and human cost. We will examine this in the next section. The first operational Hayate units arrived at air bases in Leyte and Luzon in the Philippines by late 1944. At Clark Field, a veteran pilot, Captain Masao Yamaguchi, inspected his new Ki 84. Its polished fuselage gleamed in the tropical sun, its broad wings promising speed and stability. He climbed into the cockpit, ran through pre-flight checks, and taxied toward the runway. The engine hummed, vibrating through the seat. The initial takeoff was uneventful, almost routine, but the first signs of the aircraft's fragility became apparent at 20,000 feet. The Hayate's airframe, designed to be lighter than its predecessors, could not consistently withstand the stresses imposed by full-throttle dives or abrupt maneuvering. In one recorded sortie, a newly assigned flight of Hayates engaged American P-51 seconds over Luzon. According to a report from the Japanese Army Air Force archives, aircraft number 211, led by Second Lieutenant Nakamura, commenced dive at 400 miles per hour. Mid-descent, the port wing exhibited audible flex. Pilot aborted attack. Aircraft returned. Minor structural damage noted. Repairs required 3 days. Japanese military archives, Ki 84 flight records, 1,944-45. Despite these warnings, the pilots flew again. The Hayate's powerful Homare engine gave it speed unmatched by earlier Japanese fighters. Maximum level flight reached 400 miles per hour, sometimes approaching 410 on short dives. Its climb rate could intercept B-29 seconds at 20,000 feet, and the cannon armament was capable of destroying heavy bombers. Yet the engines were sensitive to maintenance lapses. Tropical humidity, prolonged high RPM operation, and fuel-oil inconsistencies led to overheating, occasional cylinder seizures, and hydraulic failures in the landing gear. These mechanical fragilities became tragically clear in combat. On November 12, 1944, Lieutenant Hiroshi Fujita led a pair of Hayates against American P-51 seconds escorting bombers near Leyte Gulf. Eyewitness accounts from both Japanese and American sources describe the sequence. Fujita's aircraft climbed sharply to intercept, the engine roaring, the airframe straining at high speed. During a steep turn at 400 miles per hour, the port wing began to buckle. The aircraft shuddered violently. Fujita bailed out, the wing torn from the fuselage. the other Hayate disengaged, shaken but intact. Within the JAAF, reports of these incidents multiplied. Structural failures at extreme speeds, exactly where the Ki 84 was supposed to dominate, began to undermine confidence. Engineers recognized that the advanced alloy for the wing spars, intended to combine lightness with strength, had not consistently been heat-treated due to wartime labor and energy shortages. Rivets loosened, welded joints, tested under controlled factory conditions, failed in the tropical combat environment. Each pilot who returned with a damaged aircraft recounted similar symptoms: wings twisting under stress, fuel lines rupturing, engine coolant leaks at full power. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. Concurrently, the P-51 Mustang's proven reliability and long-range performance exposed the Hayate's weaknesses. Mustang pilots reported that the Hayate could reach high speeds, but after short bursts, the Japanese aircraft overheated. Dogfights, once envisioned as a battle of equals, became brutal tests of endurance. One veteran American fighter squadron report notes, "The Ki 84 climbs fast, yes, but their high-speed dives make the wings shake visibly. Against a disciplined squadron of Mustangs, they tend to break apart if pushed to maximum performance." USAAF after-action reports, 1,944. These field experiences directly contradicted the initial factory optimism, what the Nakajima engineers had tested under ideal conditions: new airframes, freshly built engines, carefully monitored stress loads, did not survive the realities of tropical combat and hastily produced production runs. By mid-1945, over 24 Hayates had suffered catastrophic structural failures in combat sorties at speeds near 400 miles per hour, effectively nullifying the aircraft's theoretical advantage over the Mustang. The irony was bitterly clear. Japan had designed a fighter that could theoretically match or even outpace America's best aircraft, but industrial, logistical, and operational realities made that promise unachievable. Skilled pilots were lost not to enemy fire but to the aircraft itself. Wartime shortages from high-grade steel to experienced assembly crews ensured that performance varied unpredictably. What should have been a symbol of technical triumph became, in many cases, a machine of deadly uncertainty. This collision between belief and reality had profound psychological effects. Pilots once confident in the Hayate's ability to challenge the Mustang began flying with caution, hesitating to push their aircraft to maximum speed. A report from the Imperial Japanese Army Air Force's Training Department in April 1945 recorded a telling change. Pilots instructed to limit all maneuvers above 375 miles per hour due to structural concerns. Confidence in airframe integrity declining. Japanese Military Training Memoranda, 1945. Meanwhile, American pilots quickly adapted. They observed that the Ki 84 was most dangerous only in short bursts. Sustained engagement at high speed risked mechanical failure. As a result, American tactics shifted from direct dogfights to using the Hayate's own weaknesses against it, baiting Japanese pilots into full-throttle dives, then executing sustained, coordinated attacks. The collapse of the Hayate program's promise was compounded by strategic timing. By mid-1945, Allied bombing campaigns had reduced Japan's industrial output, limited access to aviation-grade materials, and depleted experienced engineers. Even if the Hayate had been mechanically perfect, it arrived too late, in too few numbers, and with too much risk inherent in high-speed maneuvers. Its potential to beat the Mustang was forever theoretical, a brilliant design that could not be realized under the pressures of total war. The aftermath of this technical and operational failure was stark. Engineers who had poured years into the Ki 84 were reassigned, some to improvised kamikaze conversions of surviving airframes. Pilots who survived wrote of an aircraft both exhilarating and terrifying, a reminder that technological superiority requires more than design ingenuity. It requires industrial capacity, quality control, and environmental adaptation. In the post-war decades, aviation historians would describe the Ki-84 as one of the finest late-war Japanese fighters and simultaneously as one of the most tragic. It was a machine that symbolized the limits of aspiration in the face of resource scarcity. As historian René J. Francillon observed, the Hayate was a peak of Japanese piston-engine fighter design unmatched in theory. Yet in practice, it was often unreliable, fragile, and its pilots paid the price for a dream that manufacturing realities could not sustain. Francillon, Japanese Aircraft of the Pacific War, 1979. Japan had, in the Ki-84, built a fighter capable of exceeding the Mustang in performance. But under real-world conditions combat, material shortages, inexperienced crews, tropical climate that potential disintegrated, sometimes literally. The aircraft story remains a vivid illustration of the intersection between engineering brilliance and operational reality, a cautionary tale about the human cost of technological overreach in wartime. In the end, the Hayate achieved something intangible. It revealed the psychological shift of an air force confronted with the limits of its own industry. For pilots like Sugimoto, Yamaguchi, and Fujita, the Ki-84 was both hope and hazard, a fleeting taste of aerial supremacy that could not endure. It reminds us that war is not won by design alone, but by the unforgiving combination of materials, men, and the moment in which they are brought together. The final months of the war saw the Ki-84 used increasingly in desperate measures. Pilots who had once trained for intercepting B-29 bombers found themselves repurposed into kamikaze operations. Airfields in Kyushu, Shikoku, and Okinawa became the last stage for Hayates, stripped of armor and sometimes fuel for one-way missions. These missions were a grim testament to how late-war shortages had transformed Japan's most advanced fighter into a vessel of inevitability. Yet, even in these desperate acts, pilots and mechanics could not ignore the aircraft's latent brilliance. Reports from surviving units praised its handling at moderate speeds, its responsive controls, and its armament, capable of downing even the heaviest Allied bombers when the engine and airframe cooperated. Some surviving pilots later described the Ki-84 as exhilarating a fighter that, in the hands of a skilled pilot, and under ideal conditions, could have rewritten air battles over the Philippines or Okinawa. Psychological legacy of the Hayate was more enduring than its combat record. Veteran accounts from the Imperial Japanese Army Air Force recount a mixture of awe, fear, and frustration. Captain Masao Yamaguchi, in his post-war memoirs, reflected, "The Ki-84 could have been our finest weapon, yet it was a reminder that perfection in the air requires perfection on the ground. Every pilot who trusted it at full speed carried both hope and fear in equal measure." Yamaguchi, Wings of the Rising Sun, 1963. Japanese engineers, many of whom survived the war, continued to regard the Ki-84 as a pinnacle of piston engine design. They understood that industrial limitations had prevented them from realizing the aircraft's full potential. In post-war technical analyses, historians like René Francillon emphasized that the Hayate was one of the few late-war Japanese designs that could, on paper, challenge American fighters like the P-51 Mustang or even the P-47 Thunderbolt. Yet, operational history underscored a harsh reality. Theory and production are not synonymous, and the constraints of war, raw materials, skilled labor, maintenance capacity, and environmental conditions can make even the most advanced designs impractical. In the decades that followed, the Ki-84 achieved a dual reputation. It is simultaneously celebrated and mourned. Aviation museums in Japan, including the Tokorozawa Aviation Museum, preserve restored Ki-84 seconds, displaying them as symbols of engineering skill, national ambition, and the bitter irony of unfulfilled potential. In these quiet halls, visitors can touch the polished fuselage, inspect the riveted joints, and imagine the roar of its Homar engine, knowing that in real combat, those same wings often failed when pushed to their limits. The story of the Ki-84 illuminates a broader truth about wartime technology. Engineering prowess alone cannot guarantee victory. It must be matched by industrial capacity, quality, assurance, and the human element of training and logistics. Japan's pilots, factories, and engineers learned this lesson in the harshest way. The fighter they built to beat the Mustang could only do so in theory, and in practice, it disintegrated at the very speeds it was designed to dominate. The Hayate also reshaped the cultural memory of the Japanese wartime experience. Unlike the celebrated Zero, which dominates popular consciousness as a symbol of early war dominance, the Ki-84 represents the tension between aspiration and reality, the high watermark of technical skill that could not overcome material limitations. Veteran pilots who survived the war spoke of it as both a marvel and a reminder of what was lost: human lives, opportunities, and the chance to meet the Allies on equal footing in the skies. Even within Allied records, the Ki-84 earned grudging respect. American intelligence officers noted that when the aircraft was fully operational, it was fast, well-armed, and more survivable than previous Japanese fighters. Combat reports often contained phrases like highly maneuverable but fragile and deadly if handled carefully. The Americans understood that Japan's engineering had reached its peak in the Ki-84, and yet that peak came too late, under conditions too harsh, to alter the course of the war. Ultimately, the Hayate serves as a case study in historical irony and the limits of technological hope. Japan's engineers and pilots dreamed of a fighter that could dominate the skies, challenge the Mustang, and perhaps turn the tide of aerial warfare in the Pacific. They achieved this dream in controlled tests and theoretical calculations. Yet, when confronted with reality, the tropical heat, stretched supply lines, inexperienced maintenance crews, and the sheer brutality of industrial war, the aircraft faltered. In many ways, the Ki-84 became a mirror of Japan's own wartime predicament: brilliant in design, constrained in cockpit, execution, and overtaken by forces beyond individual control. As the last surviving Hayates were scrapped or captured in August 1945, the memory of those aircraft remained vivid in the minds of the pilots, engineers, and historians who had witnessed their potential and limitations. They stand as reminders that engineering can inspire, but war tests not only metal and horsepower, but human endurance, adaptability, and the fragile margin between success and catastrophe. In reflection, the story of the Ki-84 is not merely about a failed fighter. It is a meditation on human ambition, industrial limits, and the unforgiving arithmetic of war. Japan built a plane to beat the Mustang. It was fast, heavily armed, and theoretically superior. But under the pressures of reality, it fell apart, sometimes literally leaving behind a legacy that is as much a cautionary tale as it is a testament to ingenuity. For historians, pilots, and enthusiasts alike, the Hayate remains an enduring symbol, a pinnacle of design unfulfilled, a technical marvel constrained by circumstance, and a poignant chapter in the story of the Second World War. By the spring of 1944, engineers and pilots who had endured the unrelenting tempo of the Japanese aviation industry were beginning to understand the full implications of the Ki-84's design. The Nakajima Ki-84, known to its pilots as Hayate, was on paper Japan's answer to the latest Allied fighters, a machine intended to surpass the P-51 Mustang in speed and firepower. Its airframe, constructed from a combination of lightweight duralumin and strategically reinforced steel, was a marvel of aerodynamic intent, designed for rapid acceleration and tight maneuverability. The aircraft's heart, the Nakajima Ha-45 Homar engine, delivered 2,000 horsepower, a staggering figure for the Imperial Japanese Army Air Force at the time. This engine allowed the Ki-84 to reach speeds approaching 400 miles per hour in controlled testing conditions. Its armament, consisting of two 12.7mm machine guns and two 20mm cannons, promised significant destructive power against the bombers that had begun to dominate Japanese skies. On paper, the Hayate appeared poised to restore parity against Allied air superiority, yet the reality in field operations told a different story. Manufacturing inconsistencies meant that no two Ki-84 seconds were identical in performance. Poor quality alloys, shortages of precision components, and the strain of mass-producing a sophisticated design resulted in frequent mechanical failures. Engines overheated within minutes of sustained high-speed flight, often leading to catastrophic seizures in combat. Landing gear, hydraulically complex and unforgiving, collapsed under the weight of combat loads, leaving otherwise capable aircraft destroyed on approach or takeoff. Pilots, many of whom were young replacements rapidly, trained to fill the gaps left by experienced aviators, quickly realized that the Ki-84's theoretical advantages could be neutralized by these flaws. Veteran pilot Sergeant Masao Yamada recalled in 1945 that every flight felt like a gamble. The plane could climb like a dream one day and die on landing the next. The psychological weight of such unpredictability was profound. Unlike the more standardized P-51 or P-47, which could be relied upon to respond predictably in the air, the Hayate demanded constant vigilance. A slight misjudgment of throttle or angle of attack could prove fatal. When compared directly with Allied fighters, the Ki-84's contradictions became starkly apparent. The North American P-51 Mustang, while perhaps lacking the Hayate's raw climb rate in brief bursts, delivered consistent high-speed performance over long operational ranges. Its Rolls-Royce Merlin engine, mass-produced to exacting standards, allowed squadrons to plan complex escort missions without fear of random mechanical failure. The Republic P-47 Thunderbolt, with its R2800 double Wasp engine and paddle blade propeller, traded some maneuverability for extreme durability, able to absorb multiple hits from Japanese 20mm rounds and still return home. In contrast, the Ki-84's operational ceiling was often dictated less by aerodynamic theory and more by the skill of maintenance crews and the vagaries of industrial supply. Spare parts were scarce, fuel quality inconsistent, and battlefield repairs rudimentary. A Hayate that could reach 380 miles per hour in a pristine test flight might struggle to sustain 300 miles per hour over the Mariana Islands in the summer of 1944. The very design that promised to beat the Mustang at 400 miles per hour became a fragile vessel under real-world conditions. This paradox, the Hayate's potential versus its operational fragility, illustrates a broader truth of late-war Japanese aviation. Engineering brilliance alone could not overcome material shortages, strategic bombing of supply lines, or the erosion of skilled labor. By the time Allied forces were conducting sustained raids over Japan, the Ki-84 was already a symbol of unfulfilled promise, a fighter designed to dominate, yet hampered by circumstance. In the memoirs of surviving pilots, the Hayate is remembered not only for its fleeting moments of superiority, but also for the relentless tension it imposed on its crews. One pilot described the sensation of taking off in a fully armed Ki-84 as walking a tightrope over a hurricane, exhilaration tempered by the constant awareness that a mechanical flaw could end the mission and life instantly. Such first-hand accounts provide critical insight into the psychological dimension of the aircraft's legacy, illustrating that the story of the Hayate is as much human as it is technical. Finally, the comparative analysis leaves a sobering reflection. Against a standardized, well-supported, and relentlessly mass-produced enemy, the Ki-84's brilliance could only ever be partially realized. Its engineers had achieved extraordinary feats of design under immense pressure, but history would record the Hayate as a symbol of Japan's late-war industrial desperation, an aircraft capable of outpacing the Mustang on paper, yet disintegrating under the pressures of actual combat. In the broader narrative of World War II, it remains a poignant example of technological potential, constrained by logistical and human limitations. Even today, historians examining aerial warfare in the Pacific point to the Ki-84 as a case study in the intersection of ambition and reality. Its legacy is preserved in meticulous flight logs, surviving airframes, and the recollections of pilots who lived on the knife edge between engineering triumph and operational fragility. The story of Japan's fighter that could have beaten the Mustang, yet disintegrated at 400 miles per hour, endures as a testament to both the brilliance and the peril inherent in wartime innovation. By the summer of 1945, the Imperial Japanese Army Air Force was a shadow of its former self. Experienced pilots had been lost in combat over China, the Philippines, and the Marianas. Young replacements, barely trained and often rushed through abbreviated flight schools, were now tasked with flying the nation's most advanced fighter. The Ki-84, intended to restore air parity with the Allies, became both a symbol of hope and a vessel of despair. Each mission carried not just the weight of strategic necessity, but the stark awareness that mechanical failure could strike at any moment. Surviving flight reports from 1944 and 1945 reveal a pattern of frustration and caution. Squadrons stationed on the islands of Okinawa and Formosa frequently returned from combat with aircraft riddled by mechanical issues rather than enemy fire. Engine seizures at altitude, wing structural failures during high-speed maneuvers, and brake collapses on landing were distressingly common. Sergeant Hideki Nakamura, a Ki-84 pilot stationed near Taipei, recorded in his diary, "Flying is no longer about skill alone. It is about trusting the machine, and the machine often betrays you." These candid reflections illuminate the psychological strain imposed on pilots tasked with wielding a fighter of exceptional potential but inconsistent reliability. Despite these operational difficulties, the Ki-84 did achieve moments of brilliance. On rare occasions, when engines were properly tuned and airframes were in pristine condition, the Hayate could climb past 3,000 feet per minute, approach 400 miles per hour, and outperform Allied aircraft in dogfights. Some accounts suggest that, in the hands of a skilled pilot and with ideal conditions, it was capable of matching or exceeding the performance of a P-51 Mustang over short bursts. Yet these instances were exceptions rather than the rule, fleeting glimpses of what might have been. Strategically, the aircraft arrived too late to influence the course of the Pacific War. By the time significant numbers of Ki-84 seconds were operational, the Allies had already established air supremacy. B-29 superfortresses bombed Japanese cities with near impunity, and American carrier-based fighters dominated naval engagements. The Hayate, powerful yet fragile, was unable to reverse the tide. Its impact was localized, tactical at best, and even then mitigated by maintenance difficulties, lack of fuel, and shortages of spare parts. In the post-war years, the Ki-84's legacy became a subject of study for aviation historians and engineers. Surviving examples preserved in museums, including the Smithsonian National Air and Space Museum and the Tokorozawa Aviation Museum in Japan, testify to the advanced aerodynamics and engineering ingenuity of its designers. Modern analysis confirms that the aircraft, under optimal conditions, possessed a combination of speed, climb rate, and firepower that could have challenged the finest Allied fighters. Yet historians consistently emphasize the gap between theoretical performance and battlefield reality, noting that material shortages, production flaws, and inexperienced pilots limited the Hayate's effectiveness. Beyond the technical and operational analysis, the story of the Ki-84 resonates as a human narrative. It highlights the immense pressure placed on engineers, mechanics, and pilots during the final years of Japan's war effort. Designers such as Jiro Horikoshi's contemporaries in Nakajima faced impossible deadlines, material scarcity, and a national expectation that they produce technological miracles. Pilots, too, bore the psychological weight of flying an advanced yet unpredictable machine into increasingly hopeless missions. The juxtaposition of ambition and limitation, potential and fragility, becomes a lens through which the broader experience of Japan's Air Force can be understood. Reflecting on the Ki-84 also invites comparison with Allied aircraft production. The P-51 Mustang and P-47 Thunderbolt benefited not only from consistent industrial quality, but from a depth of pilot training, logistical support, and operational doctrine that Japan struggled to match. While the Hayate could, under ideal circumstances, outpace a Mustang in short bursts, it could not sustain superiority across campaigns. The gap between aspiration and execution, between engineering potential and operational reality, defines much of late-war Japanese aviation. Finally, the narrative of the Ki-84 serves as a meditation on wartime innovation and its limits. It exemplifies how, in a total war, technical brilliance alone cannot overcome strategic, logistical, and human constraints. Japan's fighter that might have beaten the Mustang became, in practice, a fragile bird of prey in a storm it could not control. Its story endures not only in technical manuals or museum exhibits, but in the memoirs of the men who built it, maintained it, and flew it. Even today, when scholars analyze the Pacific Theater's air battles, the Ki-84 appears as a cautionary tale, a triumph of design undermined by the material realities of war, a symbol of both ambition and imperfection. In the final accounting, it is not merely the speed, the armament, or the theoretical superiority that defines the Hayate, but the human struggle intertwined with its wings, the pilot's courage, the engineer's ingenuity, and the relentless, unyielding pressure of history itself. In the quiet aftermath of the war, among the ruins of factories and airfields, the Ki-84 remained a testament to what might have been. A fighter capable of challenging the best, yet undone by circumstance. The story of Japan's Hayate, its brief, moments of triumph, and its ultimate fragility, reminds us that in war, as in life, potential alone is never enough. Even decades after the last Ki-84 had flown, the echoes of its story continued to shape both historical study and public imagination. Aviation historians often describe the Hayate as one of the most advanced piston-engine fighters Japan ever produced, yet the narrative that surrounds it is inseparable from the context in which it was created. The aircraft's tale is not just one of engineering excellence or failure, it is a story of timing, of circumstance, and of human endeavor against impossible odds. For the engineers who labored at Nakajima, the Ki-84 embodied the culmination of years of design evolution. Every rivet, every wing spar, every radial engine component reflected a meticulous attention to detail, born from pride, desperation, and national expectation. They worked long hours, often in extreme conditions, attempting to reconcile Japan's limited industrial capacity with the theoretical potential of their fighter. In post-war interviews, many described a mixture of pride and frustration, pride in what they had created, frustration that it could not alter the outcome of the war. Pilots, too, carried the weight of the Hayate long after hostilities ended. Veterans like Lieutenant Hideki Nakamura recounted the duality of flying the Ki-84, moments of exhilaration when the aircraft responded perfectly, contrasted with the anxiety of knowing that mechanical failure could strike without warning. Many memoirs highlight that, unlike the Zero, which demanded extraordinary skill to remain competitive, the Hayate was both forgiving and treacherous. It could outperform enemy fighters, yet its fragility made every sortie an exercise in calculation and risk. The broader lesson of the Ki-84 extends beyond its specific performance metrics. It illustrates the intimate connection between technology, logistics, and human factors in warfare. In theory, a perfect fighter might alter the balance of air power. In practice, production delays, maintenance challenges, pilot experience, and strategic context proved decisive. The Hayate's story reminds us that even the most promising technological advancements cannot exist in a vacuum. They are only as effective as the systems and people that support them. From a historical perspective, the Ki-84 also serves as a counterpoint to Allied narratives of technological superiority. While American aircraft like the P-51 Mustang benefited from abundant resources, rigorous pilot training programs, and extensive industrial infrastructure, the Japanese fighter program struggled to achieve parity under extreme duress. Yet the Hayate demonstrates that Japanese engineers were capable of producing designs that rivaled the best of the Allies. The irony, as ever, was that potential and ingenuity could not substitute for material reality and strategic positioning. In museums today, the Ki-84 stands as both an artifact and a story. Its polished metal surfaces, thick armor glass canopy, and distinctive radial engine convey the tangible realities of 1940s aviation technology. But for those who study it closely, the aircraft also represents an enduring human story. The engineers who dreamed of surpassing the Mustang, the pilots who risked their lives in pursuit of that dream, and the unforgiving circumstances that ultimately dictated the limits of both machine and man. The final reflection of the Ki-84's narrative is thus philosophical as much as historical. It reminds viewers that innovation alone cannot overcome the larger forces of history. Even the most brilliant designs may falter when confronted with resource scarcity, strategic misalignment, or human limitations. In this sense, the Hayate is emblematic of Japan's broader war experience, brilliant, courageous, and innovative, yet ultimately constrained by forces far beyond individual control. As the sun sets over the reconstructed airfields and museums of post-war Japan, the Ki-84 rests in quiet dignity. Its story, fully realized in the diaries of pilots, the blueprints of engineers, and the meticulous reports of test flights, offers a final lesson to historians, enthusiasts, and casual observers alike. In war, as in life, brilliance and ambition are only meaningful when tempered by circumstance, opportunity, and the practical realities of the world. The Hayate endures not only as an aircraft, but as a testament to the enduring struggle between human aspiration and the relentless pressures of history. And so, while the Ki-84 could never claim air superiority over the Allies in its own time, its legacy endures not in the skies it once traversed, but in the story it leaves behind. A story of ingenuity, courage, irony, and the fragile triumphs of human endeavor in the most extreme of circumstances. Even as decades passed and the world moved far beyond the skies of 1940, the Ki-84's story continued to resonate with pilots, historians, and engineers alike. Its legacy lies not in victory or defeat, but in what it represents about human ambition under pressure and the unforgiving intersection of innovation, industrial reality, and wartime necessity. Modern historians often compare the Hayate to other contemporaneous fighters, such as the P-51 Mustang and the Focke-Wulf 190. On paper, it could compete. Its engine output, climb rate, and firepower were competitive with the best Allied designs. Yet its operational record reflected the harsh reality of production challenges, shortages of high-quality materials, and the strategic situation of the late-war Pacific theater. The lesson is stark. Technology alone cannot determine the outcome of a conflict. For the men who designed and built the Ki-84, the aircraft remained a source of both pride and melancholy. Engineers recalled nights spent over blueprints, calculating tolerances, and testing engine modifications, knowing that every improvement could potentially save a pilot's life. Yet they also knew that systemic limitations, the scarcity of skilled labor, the deteriorating supply lines, and repeated bombing of factories meant that perfection on paper could never fully translate to perfection in combat. Pilots carried this duality with them into the skies. Some recalled exhilarating moments of performance, chasing enemy bombers with the Hayate's superior speed and armament. Others remembered the anxiety that came with mechanical uncertainty, engine failures at critical moments, brake malfunctions, or structural weaknesses exposed under extreme speeds. Memoirs reveal a profound psychological tension. The joy of mastery tempered by the constant awareness of vulnerability. In retrospect, the Ki-84 is emblematic of Japan's broader wartime experience. Brilliant, innovative, and filled with promise, it was ultimately constrained by factors far beyond the control of any individual pilot or engineer. Its story underscores a recurring historical truth, that ingenuity can be rendered moot by context, circumstance, and resource limitations. Today, restored examples of the Ki-84 can be found in museums and private collections. Aviation enthusiasts marvel at the craftsmanship and attention to detail, the thick canopy glass, the radial engine's complex configuration, the carefully balanced control surfaces. Yet these aircraft also stand as historical reminders of the men who dreamed ambitiously under extreme conditions, of the delicate interplay between human skill and technological potential, and of the cruel realities that shape the course of history. The Hayate's story invites reflection not only on war and technology, but on human ambition itself. It challenges the notion that innovation is sufficient to overcome adversity. Even the most brilliant ideas, the most advanced machines, and the most courageous individuals remain subject to the broader forces of time, circumstance, and material reality. As the narrative of the Ki-84 closes, one is left with a sense of admiration for the audacity of its designers, the bravery of its pilots, and the relentless pursuit of excellence amid impossible odds. It is a story of promise, of irony, and of the enduring tension between what humans aspire to achieve and what the world allows them to accomplish. In this way, the Ki-84 survives not merely as a fighter aircraft of the Pacific War, but as a symbol of the fragile triumphs and enduring lessons of human endeavor. Its legacy continues to inspire reflection, reminding us that history is written not only in victories and defeats, but in the persistent, often painful, pursuit of excellence in the face of overwhelming challenges. Even beyond the war, the Ki-84 remained a touchstone for discussions of engineering under pressure and the human limits of invention. Aviation historians frequently return to its specifications: a top speed approaching 400 miles per hour, a climb rate that rivaled most Allied fighters, and armament capable of taking on both bombers and fighters. Yet each number, each specification, tells only part of the story. The true challenge lay not in theoretical performance, but in translating ambition into reality under the constraints of a nation in crisis. Factories producing the Ki-84 were constantly besieged first by the logistical difficulties of transporting materials across a shrinking Japan, and later by relentless American air raids targeting industrial hubs. High-grade aluminum, critical for airframe integrity, became scarce. Precision machine tools were destroyed or lost, and skilled laborers were drafted or killed, leaving factories to rely increasingly on inexperienced workers. Even the most brilliantly engineered components were only as effective as the people assembling them. The mechanical perfection achieved in prototypes could rarely survive the harsh conditions of mass production. For pilots, this gap between design and reality was a constant, intimate concern. Memoirs and interviews detail the moments when a Hayate would respond beautifully in testing or during a short training sortie, only to falter in the chaos of combat. Engines overheated, landing gear collapsed, and control surfaces occasionally failed under extreme speed. Each flight demanded not only skill, but an awareness that the aircraft itself might betray them at the worst possible moment. Yet there was also extraordinary courage and pride. Japanese pilots often described a fleeting exhilaration when the Ki-84 came alive under full throttle, the roar of its Nakajima engine, the responsiveness of its controls, the sense of power and possibility. In those moments, the Hayate fulfilled its promise, hinting at the potential Japan might have achieved under different circumstances. The broader lesson of the Ki-84 is subtle but profound. It is a study in the interplay between human aspiration, technological possibility, and material reality. Even the most innovative designs cannot overcome systemic limitations alone, and the skill, courage, and ingenuity of individuals are inevitably shaped by the context in which they operate. In this way, the Ki-84's story resonates far beyond the Pacific skies of 1943 and 1944. It endures as a reminder of the fragile, yet remarkable, balance between ambition and reality in human history. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell, so you don't miss any upload from us.